Good day to my fellow evaluators and friends. My name is Wong and I will be presenting my final year project entitled Evaluation of Pollutant Dispersion from Palm Oil Mill Boiler. My presentation will include the following, which are introduction, problem statement, objective, significance of study, methodology, result and discussion, and lastly, conclusion. Firstly, for introduction, I'll be talking about industrial air pollution. Industrial air pollution sources are the industry that involve the combustion process emit a variety of contaminants in the country that contribute to major health and environmental problems. The palm oil mill plant is one of Malaysia's primary industry that consists of combustion processes. In the palm oil mill industry, the burning process of fiber and shell as boiler fuel often creates a serious emission problem in the industry. It's clear that the emission from palm oil mill boiler have a strong impact on health and the environment. The major concern now is how to solve all of the issues caused by the palm oil mill boiler. Now the solution that I'm going to propose might not be reducing the emission, but it can definitely help in predicting what will happen when they are released into the atmosphere. Dispersion modeling can be used as an alternative to estimate the trend of dust emission in the future, help in setting its reduction target for palm oil mill, and analyze the stack emission from the palm oil mill boiler in terms of concentration and distribution. Moving on, the burning process of palm fibers and shell in a palm oil mill boiler release enormous contaminants such as particulate matter PM10 and PM2.5 and other chemical compounds such as carbon monoxide and nitrogen oxide. They treat the life of humans, animals, plants, and buildings. In the respiratory tract of humans, fine particles such as PM2.5 are easily deposited. There may be some health issues for exposed populations such as cough and certain cardiovascular diseases. Nitrogen dioxide may also cause ozone layer depletion or lead to global warming on a significant environmental pollution level. Moving on to problem statement, there are limited literature available on the air pollutant generated from palm oil mill boilers. In this regard, this study will compile the data and discuss in detail the impact of the pollutant. The compilation data will be presented to evaluate the emission from the palm oil mill boiler. In addition, the widely used dispersion models are costly, such as AER, MOD, CAL, PUFF, etc. Thus, this study will evaluate the free software available and do a comparison study between the models. In general, the objective of this study is to evaluate the performance and reliability of the dispersion models for the dispersion of pollutants from the palm oil mill boiler. Therefore, the specific objectives for this study are to analyze the stack emission from the palm oil mill boiler in Malaysia in terms of its concentration and distribution, simulate the air dispersion modeling of the gaseous pollutant from the palm oil mill boilers, and compare the air dispersion result from both models. This research will be important for us as the findings from this research can demonstrate the reliability and feasibility of the free available modeling which are GIR and Screen 3, or evaluating the dispersion of pollutant from palm oil mill boiler in Malaysia. And the finding can also help to predict the future pattern of dust emission and help to set the reduction goal for palm oil mill in Malaysia. This figure shows an overview of the emission data modeling framework introduced. First, compilation emission data from palm oil mill boiler. Second, identify the air dispersion modeling. Third, decide to use the GIL and Screen 3. In the end, the model results are subsequently compared with each other and also the emission result from previous study to evaluate the performance and reliability of the dispersion models. The GIL model simulates the dispersion of pollutant particles from the sources along with the airflow in the 3D model. GIL model can handle steady state standard mode as well as transient simulation. It also can simulate the dispersion over the entire wind speed range without any lower threshold and in all conditions of stability. The dispersion of contaminants that are not chemically reactive, dispersion in compressed terrain with the presence of the building, etc. The steps for the data simulation are shown. Screen 3 provides a simple method for obtaining estimate of pollutant concentration based on screening procedures. It was designed for easy calculation and identification of the maximum level of pollutants on the surface of the Earth. It can model the dispersion of a source of point, surface, and volume, and for analysis of short-term spreading. All single-source short-term calculations, including an estimate of maximum ground level concentrations and distance to maximum, can be performed by Screen 3. The steps for the data simulation are shown. Part of the compilation data of air pollutants generated from the palm oil mill boilers in Malaysia under specific conditions are shown in the table. Emission of carbon monoxide at Selangor was selected as a data input in the simulation. The presence of buildings was not considered in the simulation. For the result on 1st of April 2002, pollutants are discharged from the center point into several directions and most of them are dispersed to the southeast. It represented the wind blows in various angular degrees. This shape differs from the contour shape from the previous study in some ways. This can be attributed to the fact that the flue gas exit velocity with relatively high speed head against the prevailing wind and the wind direction keep changing for each hour. A detailed contour of the carbon monoxide dispersion at different levels above the ground are shown in two figures. The situation of the dispersion was different at a higher distance from the mill because the prevailing wind speed and the wind direction were the determinant factor in the area away from the mill. According to the result, the mean carbon monoxide CO concentration decreases in a higher distance from the palm oil mill boiler. By increasing the monitoring elevation of the dispersion to 6 meters, the effect of airflow from the palm oil mill is reduced a bit. At the level of 6 meters, a reduction of 1.3% is observed in a maximum concentration value as compared with that at the level of 3 meters. It means that the CO concentration will be close to the ambient value when the level is much higher. This model will produce an estimate of the mean CO concentration for a single source, without the need for hourly meteorological data. According to the result, the maximum mean CO concentration was 406.7 microgram per cubic meter at 744 meters from the point source, and after drifting downward to a distance of 1.7 km, was found to be 231.7 microgram per cubic meter. After that, it slightly came to 236.2 microgram per cubic meter at a distance of 1.9 km and dropped continuously. Finally, pollution from carbon monoxide at a distance of 25 km reached 93.1 microgram per cubic meter. The mean CO concentration decreases with the distance from the palm oil mill boiler increases. This model is a Gaussian bloom model without the input of real meteorological data and the specified pollutants. Hence, this model is unable to provide the high accuracy value and also the dispersion direction of the pollutants. The result presented in table show that the result of the simulation of the maximum concentration of carbon monoxide at different heights above the ground and its ground level concentration GRC maximum distance. The dispersion situation was different since the prevailing wind speed and direction were the determining factors. On day 1, the wind was mostly in the northwest direction and 25% of the wind speed was greater than 10 meters per second. Thus, this dispersion was emitted further from the stack when compared to day 3 and the CO concentration was diluted and distributed quickly in the surrounding area by the wind flow. Since there was 8.4% of the wind speed in between 2 to 4 meters per second on day 5, the CO concentration was diluted slower compared to others. On the other hand, the result from screen 3 has estimated the maximum CO concentration of 135.57 microgram per cubic meter based on average time of 8 hours, and it was triple that on day 5 of GIL. Without the input of meteorological data and specified pollutants, it assumed a full meteorology that represents all stability classes and wind speed. Therefore, the CO concentrations were higher than others. Perm rise affected the GLC maximum distance. The meteorological parameters which influence perm rise are wind speed, wind direction, and stability. The wind direction in the vicinity around the stack is not uniform. The intensity of turbulence will be determined by the wind direction in such situation. Rapid mixing of the perm occurs at a high turbulence intensity, eliminating the effect of perm buoyancy and momentum. Wind speed usually increases at a higher distance above the surface of the Earth. As the berm continues to rise, the stronger winds cause more dispersion. The pollutant will disperse more before it reaches a ground level when the berm is higher in the atmosphere and at a further distance from the ground. As the effective berm height increases, the maximum concentration will increase and the distance to reach the maximum concentration is longer. It means that the stronger the mean wind speed, the longer the GRC maximum distance. Since the stronger mean wind speed occurred on day 1, it has the highest GRC maximum distance among the 5 simulation results from GIAL. Lastly, conclusion. From the data compilation of gases and particulate emission of carbon monoxide and Selangor was selected as a data input in the simulation. GIL and screen tree models have been selected and tested successfully in determining the dispersion of gases pollutants. The results from both models show that the mean CO concentration decreases with the distance from the palm oil mill boiler increases. However, GIL model is more effective than the screen tree model for the estimated distribution of air pollutants because it can show the direction of dispersion and the data input of meteorological data can produce a more accurate result. Thank you for listening.